Okay, watch and listen carefully here, guys. So for question number 1, okay, we've got a 200 Newton box. Is that one of those tricks I warned you about? I didn't give you the mass, I gave you the weight of it. Okay, it's being pulled up a 30-degree incline. So here's our 30-degree incline. Here is our 200 Newton box. That means that this arrow here is 200 newtons. Okay, we got normal force over here, which won't be important on this question, and we've got F parallel on this side. That angle is the same as the angle of incline. Okay, we know that the acceleration of the box is 1.5 meters per second squared up the ramp. Okay, we know the force of friction is 15 newtons. So that's acting down the ramp because they tell us the box is being pulled up the ramp. What other forces should I put on here? F parallel and an applied force. All right. All right. This is the one I'm being asked to find here. All right. 1 mark for givens. Okay. Next thing I need to find, okay, is F parallel. I don't have to find FG because they gave it to me. All right. So F parallel will be the sine of 30 times 200 newtons, which is 100 newtons. So they can have a mark for that. Force of friction is 100 newtons. Or sorry, force parallel, sorry, is 100 newtons. Now, what can I calculate right now? Well, actually, I have to calculate this first, and then I can calculate. I need to calculate something right now. What is it? Mass. Okay. Without mass, I can't calculate the net force. So I'm going to calculate the mass. Mass is going to be the force of gravity, 200 newtons, divided by G, 9.81. So 200 divided by 9.81. All right, so they can have a mark for that step. Okay, so we got 20.387 kilograms. Okay, now I'm going to use that number to calculate my net force. So M times A. All right, so I'll have my 20.387 times 1.5. Right, so we'll give them a mark for that step as well. Okay, so my net force is 30.581 newtons. Next step, if I'm going to find the applied force, I need to know, okay, the sum of all forces. So that's going to be the applied force, which is what I'm looking for, plus F parallel, plus the force of friction. Okay? And so since I'm looking for, since I'm looking for the applied force, I'm going to manipulate like this. F net, okay, is going to equal, sorry, F net minus F parallel minus the force of friction will equal the applied force. So that will be our 30.580 okay, minus negative 100 minus negative 15, because those are down the ramp. Okay, so minus negative 100 and 115, we'll just say 115. All right, so my applied force is 145.58 newtons, but I only have 2 significant figures, so it's 1.5 times 10 to the 2 newtons up the ramp. They must have the up the ramp and the right number of significant figures to get that 5th mark there. Questions on number 1? Okay. Now, question number 2 tells us something about coefficient of friction. So they're telling us mu, okay, is 0.04, which is really, really low. Okay, so that's a very slippery surface. Okay, between a curling rock and ice, the mass of the rock is 18 kilograms. Okay, we are looking for the acceleration of the rock if it has just been released by the curler. So if the curler has just released it, what are they no longer doing? They're no longer pushing. What's the only force acting on the rock? Friction. Okay, so if they've got those givens and or a free body diagram looking like this, that's the mark for their givens. Okay. that means that the force of friction is the net force, right? I mean, the other forces are gravity and normal force, but they cancel. Okay, so can I calculate then the net force? Yes, I just have to calculate the force of friction. Okay, in order to do that, I've got to calculate the force of gravity because I need to know normal force. So my next step is calculate the force of gravity. M times G, 18 times 9.81. So they can have a mark for that. All right, so we're looking at 176.58 newtons. All right, so there's my force of gravity, which also happens to be my force normal. Okay, so I'm going to calculate the force of friction by going mu times the normal force. All right, so they can have a mark for that step. So that's going to be 0.04 times 176.58. All right, so my force of friction is 7.0632 newtons. All right, that's also my net force. So now I can do this. F net equals m times a and calculate the acceleration. So 1 mark for realizing they had to use m times a, or maybe they showed it manipulated. Okay, whichever they did, F net over m. So that'll be 7.0632 divided by 18 kilograms. All right, so 0.3924, but we only have 2. We only have 1 significant figure here. That 0 is a leading 0. Thus, you didn't measure anything there. 4 is the only significant figure in that coefficient of friction. Thus, our answer is going to be okay, and that's going to be negative. Has to be because it's slowing down. You could say backwards. Yeah, backwards, okay, negative, whichever. Okay. That is your 5th and final mark on that question. Always got to be watching for the little things, right? Always got to be watching for the little things. Okay, give them a mark out of 10. Let them see it. Nice, neat pile of them right here, please.